In this lecture we are going to talk about array, where each element of the array is next to each other. Each element of the array can be accessed by index. The index can be considered as reference indicating the place in the array. Accessing elements by index is super fast, while access of an element by value, which is an alternative way to retrieve the element from the array, are much slower, since it requires iteration from the start of the array at a certain element. Let's talk about how arrays are stored in the computer memory. Assume that at this picture we have computer memory. Of course, it is simplified view. Let's say the white squares mark free memory space and the red ones mark used memory space. Usually, operation system runs many processes and programs at the same time. That's why some memory places are always used by someone else. Now imagine we want to store a new array in the memory. We have to allocate some memory. As you can see from the picture, we have created the array of size 8. Note that each element of the array is next to each other in computer memory. Let's add some values. From programming perspective, array points to the first element in memory. The respective Java code for this state in memory would look like this. From the computer memory perspective, indexes that we use for accessing some array elements should be considered as shift from the start of the array. And the array variable, as I mentioned before, always points to the start of the array. Now let's say we want to get the second element of the array. The Java code for this operation would be as it is in the picture. We simply trying to return the array at index 2. The code looks very simple, but in computer memory we do not operate in indexes. In fact, array indexes are a programming language abstraction which makes things simple. In computer memory we have addresses which refer to specific place in memory, and the index stands for the shift from the start address of the array. As I mentioned before, the array variable indicates the start address of the array. So the get operation is performed by adding the shift of the start address of the array. The result of this operation is 24th address, which points to the second position of the array, where element 10 is stored. Similarly, if we would refer to 0th element of the array, the shift would be 0 and the element 1 would be accessed. The access by index is fast and simple because of the storing manner of the array. Array forms some sort of a memory block. The access of the memory within this block is very fast. Such storing structure also enables some low-level optimizations like effective caching, which also may speed up a computer program. Now let's look at the other case. Imagine we have filled up the array of size 8. What do we need to do if we want to add some extra values? Normally, in such situation, we would get index out of range exception. The solution is to allocate more memory for a new array. Then, we need to copy all values from previous array to new one. Finally, we have extra space and now we can add more values and free up the memory used by previous array. This case shows us that array requires some extra memory allocations when the memory space of the array is fully occupied. Since arrays are simple and fast, they are used as some sort of building blocks for other complex data structures or abstract data types, such as lists, stacks, queues, hash tables, sets, and others. The key points of this lecture would be the following. Array is fixed-size linear data structure where each element of the array is next to each other. Physical proximity on computer memory enables low-level optimizations of array, for example, effective caching. Array element access by referring to the index is very fast. Since arrays are fixed size, adding to the filled up array requires extra memory allocation. Arrays are fundamental building blocks used in many complex data structures. Thank you for your attention.